So today we have a problem of move zeros, which is a easy problem. So basically we have an array and we have to move the zeros in the array to the end. Like you can see these zeros, um, and you see 1, 3, and 12 where that have retained the order, and these two zeros on in the index 0 and 2 have moved to the last. In the second array, it's pretty straightforward. It should be 0. Yeah. So let me just explain how we are going to do it. Um, yeah. So uh, here we have an array of 0, 1, 0, 3, 12. So we have this array of 0, 1, 0, 3, 12. So let's say that um, we have two pointers. Let's assume we have two pointers left and right, both starting from the first position, that is the zeroth index. So um, what we can do here is uh, we can have a rule of move the right pointer until we find a non-zero, and when we find a non-zero, we swap it with the left pointer position. Let's see how it goes. So here right now we are in a position that we have 0 on left and right. So let's move the right pointer to a non-zero position. So that means to the second position. So we have 0, 1, 0, 3, 12. Left is here, right is here. So we have a non-zero position. So let's let's swap it. So after I'll just write the S keyword for the swap operation. So here we swapped it, right? We have the left and right. And now we have to move the left, and the right always moves. The right always moves to the next position. It's just a question that when the left moves. So left moves when there's a swapping. And when there's a swapping, that means right has encountered a zero value, right? Um, so so when we move the positions, now we have this new array, and left is here, right is here, right? So now um, again we move, left is here, right goes to the fourth position. So now it is a non-zero, 3 is a non-zero value, so we swap. So here's the swap operation: 1, 3, 0, 0, 12. So and left and right were here, so we have to move the left and the right. So what happens is uh, left goes to this position, right comes here. So again we have a non-zero, so we do a swap. So this is a swap operation: 1, 3, um, 12, 0, 0, and left, right. And of course, right is at the last index. So that means we run out of the array. And that means we have sorted everything, and the 0 is at the end of the array. So Yeah, that's what the algorithm is. But there are a couple of observations here. First observation is you see the position of the left is always at the start of the zero, you know. What I mean is left is always like like left of the left pointer, right? The left. So let me just explain here. Yeah. So left of the left pointer, right? So here there is nothing, right? So left of the left pointer doesn't have any zero, right? So let's see here. So left of the left pointer doesn't have any zero. So left pointer is at the first zero, right? So this is important. This is important. See here. So there is no zero. This is the first zero that is encountered, right? And um, so and right is always so right. So there are so what I said was there are a couple of observations for left and right. So right is always finding the non-zero. It's always finding the non-zero value, and left is always at the first zero, right? Left is always at the first zero. So that was the observation. Now, okay, so now let's go to the code section. So how do we code it? So we have the left, which will start from 0. So for right in range, so uh, right will run through the whole array one by one, and left. So if right if nums of right sorry nums of right uh, nums of right is not equal to 0, then what we do? Then we do the swap. So the swap would be nums of left, nums of right. So would be right should be left. So here's a swap, and when there's a swap, the right will, of course, automatically goes to the next right position. Will go to the next position. But we need to update left so that it is at the new position where the leftmost zero is. Correct. So return. I'm sorry. So let's see. Yep. Submitted. Yeah. Um. So how much? How much? Um. What could be the time complexity? It could be big O of n, right? So at most, it, it will run to the last index in the array. Yep. Thanks.